Hi guys, this is two-part lesson, but this is page 197. You're in section 5.2 of the book. It starts here, 5.2. So what page? Page 196. So 197, this brown box says hints for verifying identities. This is your go-to thing for concepts when you're working through identities. Now, an identity is not an equation. Look, caution, the procedure for verifying identities is not the same as that of solving equations. Techniques used in solving equations, such as adding the same term to each side, multiplying each side by the same term, should not be used. In fact, never be used. So here's the thing. When you have an identity, these are the things to look at. Know your fundamental identities. That's the tangent equals sine over cosine. Cotangent equals cosine over sine. That kind of stuff. And be aware. See how it says here? Be aware of equivalent forms, for example. Then try to write the more complicated side of the equation so that it's identical to the simpler side. That's always a good strategy. Don't pick on the easy stuff. Pick on the stuff that looks tricky and then try to make it smaller. It's sometimes helpful to express all trig functions in terms of sines and cosines. That's a good one, but it doesn't mean you always do that. Factoring. All this stuff here, these little formulas, you know them as cubes or difference of squares or whatever. It just means don't forget factoring is a good idea. So for example, and they show you a good example there, sum or difference, that just means sometimes it's a good idea to get common denominators and add or subtract things together. When you're looking at fundamental identities, sometimes you substitute things in for other things. Those are good hints. And then multiplying numerator and denominator by 1 minus sine x, if it starts, that's the conjugate idea. Now what I did is I am going to assign some problems for you guys to do. These examples on the following pages, example 1, example 2, these are all good examples, but this is where we're starting, where it says verify that each equation is an identity. So here's what I did. I picked out some even ones for you to see some strategies in motion here. So here's what I'm going to do. Problem number 36. I wrote out my steps. I'm also going to walk you through this in the next video, but you could pause this, take a picture of it, and try to figure out what I did. But notice I have LH only. That means I only worked on the left-hand side. I left the right-hand side alone. When I make the left hand match the right hand, I draw a little box, I'm done. Number 38, left hand only. I rewrote the top part as secant squared, and then I canceled, because if I have secant squared over secant, I can reduce it to this, and then both sides are identical. Now this one, number 46, I picked out because it's a factoring question. Look, you can take out a GCF of both sides, and then it's done. Now, what I'm trying to illustrate here is sometimes the thing you want to do is rewrite it using an identity. Sometimes you want to factor. All of these hints are on that brown box that I showed you at the beginning. Here's 58. I wanted to show you this because sometimes people make a mistake and they go, oh, sine fourth reduces with sine squared. Cosine fourth reduces with cosine squared. It does not. Look, the top part is a binomial. The bottom part is a binomial. They don't match exactly. You do not get to just cancel. But I did left hand only. Here's what I did. I took the top part and I said, that's the difference of squares. It's not a common looking one, but it is. Look, what times itself is sine fourth alpha? Sine squared. What times itself is cosine fourth alpha? Cosine squared. So I factored it, and then I canceled, and then I said, hey, sine squared plus cosine squared, that's equal to 1. So boom, I'm done. Now, all of the problems I showed you so far have very little work to do. And then here's 59. 59 is a sneaky problem. I had to work on both sides. So I took the left side and I created double fractions. I rewrote it so it had sine squared t over cosine squared t instead of tangent squared t. I did 1 over cosine squared t instead of secant squared t. Then I cleaned up my double fractions. If you're going to do this, show me this step. Don't leave it out. Don't let me guess. You write it in. What happens then, I get it to look like that. Well, guess what? My right-hand side, my right-hand side then, I took the original problem and I wrote it with sines and cosines. I canceled out the double fraction look, and I got it to here. And then I said, wait a minute, on the bottom I have 1, so guess what? The left-hand side ends up equaling the right-hand side. This is what it looks like in an identity when you work on both sides. Now, here's the thing. Every problem I picked out for you guys to try on day 1 should be able to be done in less than 8 steps. So here is what I consider the hardest problem. Problem number 48 starts out and you're trying to make the left and the right-hand side look the same, but they're both complicated looking. So on this side, I used the trick, multiply top and bottom by the conjugate. Remember, don't change what it is, just sign in the middle. Then I got it to here. And then I said, hey, that's the same thing as cosine squared. And that was what I got. But see, I did this one to show you what it looks like when you're actually not making any progress. This is what not to do. Look at how complicated this side was. I went, hey, I could foil this. So I foiled it. I performed what was indicated, which is foiling. But when I did that, I got it to here, I combined some stuff, I said that's the same as this, I could get it so it looked like this, but now what? Know when to stop and try a new strategy. So, on this particular problem here, what I did a second time is I took the original problem, I wrote it with sines and cosines, and then I said, hey, you guys have a common denominator, and I put them together. That was all I really needed to get it to look like this, because if I square this, it means this gets squared and that, so I wrote it like that. Hey, that was the same strategy I tried with the other side. So here I went 1 step, 2 step, 3 steps, 4 steps, 5 steps, 6 steps, and the left hand equaled the right side. Now, when you are doing more than 6 steps, you better hope that it's starting to look less complicated instead of more complicated. Now, I know this is a lot of information, so I'm going to go through this on another video, but what I was trying to get at is when you guys are trying to do the practice problems here, and I'm going to have you guys do the odds from 35 to, where is it? I wanted you to stop at 57. I will show you this again in the other thing, and that's on page 202, 203. But I wanted you to have like a view of my worked out solutions so you could just pause it, take a picture of it, and then see how I did some of the problems in case you get stuck. Now, you could come back to this lesson, you could compare it to the next lesson. The next lesson is me explaining how I went through my process. So they go hand in hand. This lesson and the other one match up. But this is the part of the book we're going to be working on. We've already done these ones here, so we're going to start down here. All right, guys. Look for my next video. Have a good rest of your day. Bye-bye.